We're going to do a quick review of probability today. So first thing, what is probability? It's the measure or the likelihood that something will happen, that an event will occur. So there's a scale here. Probability is usually measured between the values of 0 and 1. Sometimes it's written as a fraction between 0 and whatever fraction over that would make 1, like 5 out of 5 or 6 out of 6, 10 out of 10. Okay, so if it's right in the middle, that's 50% or 0.5. Either way, make sure you're comfortable looking at it in terms of being between 0 and 1 as a decimal, as a fraction, or as a percentage. Any of those combinations would be acceptable. So probability, this is some notation for probability I'm not sure if you're familiar with, but the probability of an event. Okay, so the probability of rolling a 5, the probability of pulling a red marble is the number of favorable outcomes out of the number of the number of possible outcomes. Okay, so experimental probability is when you actually perform the experiment and you write down the number of times it occurred out of the number of times you did the experiment. This should not be anything new to you. Here's an example. Quality control inspector samples 500 LCD monitors and finds defects in 3 of them. What's the experimental probability that a monitor selected at random will have a defect? Okay, so that defect happened 3 out of 500 times. So we can leave it as 3 out of 500. If you want to put that in terms of a decimal, it would be 0.006. So now, if the company manufactures 15,240 monitors in a month, how many are likely to have a defect based on the inspector's result? So we're looking at about 0.6% or 0.006, looking at our information above. So that times 15,240, that gives us about 91.44. Now, in probability, you usually say about 91 units, okay? Or you could round up to 92, but that word about there, when you're talking about whole units, it says there's going to be more than 91, but not quite 92. So you can say about 91 units or 91 to 92 units, you could say. That's how we kind of handle the rounding aspect in probability. Here's another example. A park has 538 trees. You choose 40 at random and determine that 25 are maple trees. So what's the experimental probability that a tree chosen at random is a maple tree? Okay, so we have 25 maple trees out of 40 trees that we tested. So if I look at the decimal of that, that would give me 0.625. Okay, now how about how many trees in the park are likely to be maple trees? So we know there are a total of 538 trees, and we know about 0.625 are maple, so about 62.5%. So if I take that times 538, that gives me 336.25. So about 336 maple trees. Again, that word about is key because that shows that we're rounding. All right, so theoretical probability happens when we do it based on what the numbers should say, not an experiment, but thinking theoretically. So now, the probability of rolling a 3 with a 6-sided dice. So this is that notation, the probability of 3. So we know there's 1 3 on a die. And there are 6 different possibilities, the 1, 2, 3, 4, 5, 6. So my probability is 1/6. Okay, so what I want you to do is take a minute here, and I want you to find the sum of these number cubes. So for instance, if I roll a 1 and a 1, my total would be 2. If I added a 1 and a 2, rolled a 1 and a 2, I'd have 3. Okay, so take a minute and fill out this table. All right, so I filled out my table. Hopefully you have yours filled out as well. That's going to help us answer these next couple questions. Okay, so you're going to keep referring back to this table. So I want to know, find the indicated probabilities when rolling 2 standard number cubes and adding their values together. So I really need to determine how many times, depending on how I rolled, could I get a 7. So looking at our table, we can see that the number 7 appeared 6 times, and we had a total of 36 different combinations. So if I reduce that fraction, that's really 1/6. Okay, I can do the same thing for 9, 2, and 13. So take a second and do those. Okay, so if I look at that table, I can see the number 9 appeared 4 times out of the 36. Again, I can reduce that fraction. That gives me 1/9. You can put that in terms of decimals, whichever you prefer. Okay, then probability of 2. That only happened 1 out of 36 times. Okay, the only way to do that is to roll a 1 and a 1. And then finally, the probability of 13 appeared 0 times. Okay, so our probability there is 0. Again, keep in mind when we talked about right in the beginning, having a probability of 0 means it's impossible. It cannot happen. All right, the next thing we're going to talk about is something called frequency tables. So this can be used basically just to display your data. Then it's easy to find probabilities. All right, relative frequencies means the ratio of frequency of the category to the total frequency. Again, so like the number of probable outcomes to total outcomes. Very similar, just like experimental probabilities. So here we have the results of a survey for student music preferences. What's the relative frequency of preference for rock music and then for hip hop? So here we have our frequency. The first thing we need to do is actually find that total there. So if we add that column, let's see how many people we have taking our survey. We have a total of 40 people. There's my total. Okay, so when I'm talking about rock music, we had 10 out of 40 prefer rock music. So that says about 1/4 or 0.25, however you'd like to express that. When I look at hip hop, I'm talking about 7 out of 40. Again, we can type that into our calculator if you want. That gives us about 0.175 or 17.5%. Again, however you'd like to think about it. So really, this is no different than what we were doing before. Okay, student conducts a probability experiment by tossing 3 coins, one after the other. Using the results below, what's a probability that exactly 2 heads will occur in the next 3 tosses? So 2 heads. So I'm going to look through here and figure out the number of times we had exactly 2 heads. So we have 2 heads here, 2 heads here, 2 heads here, and I think that's it. So I can't count that first column because that first column actually has 3 and it says exactly 2 heads. All right, so if I look at, first of all, if I look at just my yellow here, just the things I've highlighted yellow, I have a total of 15 occurrences. Okay, so I had a total of 15 occurrences, but I need to figure out how many attempts we made. So I need to add, I added up this column or this row here, and there were 50 trials. Okay, so I have 15 out of 50, which I can then convert to decimal if I want. That's 0.30 or 3/10, however you like to write it. Okay, here's another one. The student conducts a probability experiment by spinning a spinner. Using the result, what is the probability that it points out of 4? Okay, so again, using our table, we had a total of 100 spins this time. Okay, the number of times we had a 4 was 18, so that is 0.18. Probability distribution shows the probability of each outcome. So we've just been looking at very specific ones. Okay, and sometimes you want the probability of all the different events, and a lot of times you can include it in the table. So in a recent competition, 50 archers shot 6 arrows each at each target. 3 archers hit no bullseyes, 5 hit 1, 7 hit 2. Okay, on and on and on. What's the probability distribution for the number of bullseyes each archer hit? So the number of bullseyes hit, let's see, 3 archers hit no bullseyes. So 0 and 3 people hit it, or did not hit anything. So 5 hit 1 bullseye. So number of bullseye is 1. 5 people did that. 7 hit 2 bullseyes. 7 hit 3 bullseyes. 11 hit 4 bullseyes. 10 hit 5 bullseyes. And 7 hit 6. So I want to know the probability distribution for the number of bullseyes each archer hit. First thing I need to do is just figure out how many archers did we have. So in our case here, we had 50 archers. Okay, so now I can go through and figure out the probability of hitting 0 is 3 out of 50, or 0.6 if you want to do it in your calculator. The frequency of hitting 1, that would be, 5 out of 50, which is 0.1. Okay, then we have 7 out of 50, 7 out of 50, 11 out of 50, 10 out of 50, 7 out of 50. Okay, so again, we can find the decimal equivalent of all those. Okay, so the probability, again, can be expressed either as a fraction or a decimal. Both are very much appropriate. The only time you would have to pick one or the other is probably if it just said so in the direction. Like express your answers in decimal form or express it in fraction form. All right, on a math test, there were 10 scores between 90 and 100, 12 scores between 80 and 89, 15 scores between 70 and 79, 8 between 60 and 69, and 2 scores below 60. What's the probability distribution for the test scores? All right, so first I'm just going to kind of create a table here. All right, so we have between 90 and 100 is one category. We have 80 to 89, 70 to 79, 60 to 69, and below 60. All right, so now I'm just going to write down the frequency of when that happened. So we were 10 scores here. We had 12 scores between 80 and 89, 15, 8, and 2. So now if I want to find the distribution, first of all, remember I got to find my total. So how many people took this test? So we had a total of 47 people take the test. All right, so now I just take 10 out of 47, 12 out of 47, 15 out of 47, 8 out of 47, and 2 out of 47. Okay, again, put it in decimal if you like, or you can leave it as a fraction. Okay, now I'd like you to attempt day 1 homework. It looks like it's long, but really this goes pretty quickly.